Hi, today we are on pages 13 and 14 in our notes, and we are going to talk about surface area of pyramids. So, a pyramid has a unique measurement called a lateral height. Okay, and what that is it actually is the measure of the height of one of the triangular faces. Okay, so we have these four different pyramids, and we are just going to label each part of it and then talk about what type of pyramid it would be labeled. So first we have what would the base be? Again, the base is kind of like your bottom for triangles. So the base would be this bottom right here. It would be your bottom right here. It would be the bottom right here and the bottom right in the middle. Okay. Next, we have the faces, which if you look at a pyramid, it would be like the sides. Okay, so I'm going to put like a little tilted F, little tilted F, and like a little tilted F. Okay. And then like if you would enclose these would be all your faces. Okay. Then we would again, if it was folded up, it would look something like that. You would have these faces on the left, the right, and the back side. And then the same thing, if you were to fold it up, you would have these three faces. Okay. And what a lateral height is it is the height of one of the faces. So like right here, how it's kind of tilted and it gives you how tall this triangle is. This is called our lateral height. And we use a lowercase l for that. Okay. So for this one, this is not folded up. So we would take one of the faces and we would label how tall it is with a little cursive L to say lateral height. Okay. This one would be our lateral height right here. And then however tall one of our faces would be, that would be the lateral height. Okay. Now we are going to label these shapes. Okay. So we look at the bottom first. Okay. And because the base is a rectangle, this is a rectangular pyramid because it comes to a point. Okay. This is also a rectangular pyramid because the base is a bottom. And if I were to fold it up, it would go to a point. So I'm going to put that as well. Okay. Now for this one, this base is actually a triangle. So is this one. So this is a triangular pyramid. Because both of these come to a point, and if you were to fold that one up, it would also come to a point. Okay. Which shapes make up the pyramids above? Okay. So for like these two, we had triangles for the faces because they became a pyramid, they went to a point, but the bottom was a rectangle. So we had rectangles and triangles for the first two. And then a triangular prism, we had a triangle for the base and also triangles for the faces. So these were just triangles. Okay. All right. The base of a pyramid, so the bottom of a pyramid, is going to determine how many faces will be included. I mean, how many total faces would be included. Okay, because if you have a rectangle at the bottom, you would have four sides that would come to a point. If you had a triangle at the bottom, you would have three faces that would come to a point. Okay, so we have this thing that is decomposed, and we are going to find the total surface area of it. So we are just going to break it up into pieces. So first, let's just do the easiest one. The base is a rectangle, so let's just do 6 by 7, and that would be 42 square millimeters. Okay, and again, I only have one of them. It's the bottom. I don't have another one on top, so that is my total. Okay. Then we have our triangles, our ones that come to a point. So first, let's do this one. I'm going to change colors. Okay. Okay. So I have a 6 millimeter by 7 millimeter. Okay, and I'm going to when I multiply those, I get a rectangle, and I get 42. But again, this is a triangle, so I'm going to cut it in half. Okay, so 42 divided by 2, which would be 21 square millimeters for this top one. Okay, and then I asked myself, do I have another one that's like that? And that would also be this bottom one. So I am going to double it, and I get 42 square millimeters. Okay, next one, we have this left and the right side. Okay, so I have 6 by 6. And again, this is the lateral height, so it'd be also 6. So we would multiply 6 by 6 and get 36. But again, it's a triangle, so let's cut it in half. And so half of 36 would be 18 square millimeters. Again, I have this left side, but I also have this right side, so I am going to double it. And I do get 36 square millimeters. Okay. Then to find the total, I'm going to add 42, 42, and 36 together. And I get 120 total square millimeters to cover this pyramid. All right. Determine the surface area of the objects below. Be sure to note the shape of the base as its lateral and its lateral height. Okay, so if I look, this brick rectangular prism, so that is the base of it, is being painted gold. It has a lateral height of 12 millimeters. So the lateral height is 12 meters, excuse me. How many square meters will be covered? Okay, again, if I'm painting something in gold, I don't need to paint the bottom of this pyramid. So that's why it says lateral height, where I'm not going to put the base into this problem. Okay, so what we're gonna do is we are gonna find the front and the back, and then the left and the right side. Okay, so I'm gonna do this one first. Okay, so I'll call this left and right. Okay, and it looks like it is 8.5 meters long, and then it says that the lateral height is 12 meters, excuse me. Okay, so I'm going to multiply 8.5 by 12, and that will make a rectangle, but we are dealing with triangles, so we do need to cut that in half. So 8.5 times 12, cut in half, would be 51 square meters. Okay, but keep in mind, this side that we can see on the front would also have its matching side on the back, so we are going to double that and get 102 square millimeters. Okay. All right, next we have this other side. So we'll kind of call that one the front and the back. Okay, so this triangle is 9.6 meters long. And again, it said that the lateral height was 12 meters. So we are going to multiply 12 times 9.6. And it's a triangle, so we are going to cut in half. 12 times 9.6 is 115.2, cut in half. We get 57.6. Again, we have the front, we also have the back, so we do need to double it, and we get back to 115.2 square meters. If you guys are seeing a shortcut, like if we have a triangle, we cut it in half and then we double it, you just have to make sure that you do have two sides to use that shortcut. And then we will add those two together, 102 for the left and right side, and then 115.2 for the front and back, and we get 217.2 square meters. All right, this one says, what is the total surface area of this square pyramid? So the base is a square, so that means that each side is 6, okay? And we have a lateral height of, it looks like the lateral height is 4, okay? So if we think about this number right here, this would kind of be like if you had this picture, it would go like this. That would be like right here. Okay, that's not very important for us to find the area of these shapes. So we actually don't even need the number 5 in this problem. Okay, so first let's do the base or the bottom. Okay, so the base is a square, so we have a 6 by 6, which would be 36 square feet. And again, I don't have a top and a bottom, I just have this bottom, so that is the only one. Okay, then let's do one of the faces. So it's a triangle. We have 6 as the bottom number, and the lateral height is 4. So we're going to do 4 times 6. Again, that would be a rectangle, so we need to cut it in half. So 4 times 6 is 24. Cut in half would be 12 square feet. Now we have to figure out how many of these shapes do we have. So this is a square, which means they're all the same. So I have one, I have the left and the right, but I also have the top and the bottom because it is a square. So what we can do is we can multiply that by 4 and get 48 square feet for our faces. Then to find the total, add the base with the 4 faces, 36 plus 48, and we get 84 square feet for our total surface area. Okay, last one. It says lateral surface area. All the lateral faces and the base are congruent. What is the lateral surface area of the pyramid? Okay, again, it's saying lateral surface area, so it is saying to not count the base, so no base. So this base is not very important, but it does tell us that the lateral height is all the same. So that means that this is 15 centimeters. Okay, so we're going to do the faces. Okay, we know that it is 16 centimeters on the bottom, and it has a lateral height of 15 centimeters. So we're going to multiply that. But again, it's a triangle, so we have to cut it in half. So 16 times 15 is 240, cut in half, and that is 120 square centimeters. Okay. Now I have to think about how many that we have. We have this one, and this one. So we can multiply that by 3, and we get 360 square centimeters. All right, today we have some Delta math practice.